Hi, hello everybody. This is your Srinivasa. Welcome to Srinivasa Academy. My dear students, నేను ప్రామిస్ చేసినట్టుగానే మీకు ఎవ్రీ డే ఒక అద్భుతమైన కాన్సెప్ట్తో అద్భుతమైన షార్ట్ కట్స్తో మీ ముందుకు వస్తానని ప్రామిస్ చేయడం జరిగింది. టిల్ టు ఎగ్జామినేషన్ ఎవ్రీ డే మార్నింగ్ 6 o'clock one new video will be released with useful content. So in that process, today I have come in front of you with another important concept, that is limits. Continuation to this, we get continuity also. Dear students, I think you know already what is the importance of limits. Minimum 2 to 3 questions we can expect with easy models. Just there will be few models. Let's discuss about complete picture about limits. Okay, do observe that first. What is the limit concept? Suppose f of x is equals to x plus 3. F of x is a real valued function defined as x plus 3. Consider x values corresponding f of x values. Suppose x value is 1.9, corresponding f of x value 4.9. X value 1.99, while substituting here f of x value will be 4.99. X value 1.999, f of x value 4.999. X value 1.9999, f of x value 4.9999, and so on and so on. Do observe that in the first sequence x value never be equal to 2. And in the second sequence f of x value never be equal to 5. But left to right the values of x are increasing type. From left to right the values of f of x are also increasing type. So this situation is denoted by x tends to 2 minus. This situation is denoted by x tends to 5 minus. X tends to 2 minus stands for x value is less than 2. X value is not equals to 2 and less than 2. What it says? X less than 2 and x is very closer to 2. X less than 2 means don't think that x value 1 also. No, it is very closer to 2 and less than 2 is denoted by x tends to 2 minus. In the second sequence corresponding f of x values trying to approaching 5, but they never be equal to 5. So they are approaching 5 from left side of 5. Means all the values of f of x are less than 5. So that is the situation is denoted by f of x tends to 5 minus. Consider one more sequence 2.1. F of x will be 5.1. This is 2.01, 5.01, 2.001, 5.001, 2.0001, 5.0001, etc. Do observe that in the first sequence x values left to right decreasing and they never be equal to 2, but they are approaching to 2 from right hand side of 2. So in the second sequence they are approaching to 5 from the right hand side. Each value of x is greater than 2. Each value of x is greater than 2, but never be equal to 2 at any stage. In the second sequence also, each value of f of x is greater than 5, never be equal to 5. Okay, so that's why either x tends to 2 minus or x tends to 2 plus, it is denoted by x tends to 2. X tends to 2 minus or x tends to 2 plus, it is denoted by x tends to 2. F of x tends to 5 minus or f of x tends to 5 plus, it is denoted by f of x tends to 5. Okay, do observe that here plus or minus represents the direction simply. So x tends to 2 means, what does it mean? X may be less than 2 or x may be greater than 2. F of x tends to 5 means f of x may be less than 5 or f of x may be greater than 5. So this is the situation. But whenever f of x tends to 5 as x tends to 2, this situation is denoted by limit x tends to 2, f of x is equals to 5. In this case, very clear, x not equals to 2, f of x not equals to 5. This is very clear, x not equals to 2, f of x not equals to 5. What does it mean? X tends to 2, f of x tends to 5. That is the meaning. Okay? And also, do observe that, suppose limit x tends to a minus f of x is equals to L. Limit x tends to a plus f of x is equals to L. Then only we say that, then only we say that limit x tends to a, f of x is equals to L. This is called left hand limit. This is called right hand limit. Whenever left hand limit is equal to right hand limit, then only we say that limit of a function exists and it is equal to L. Sometimes we can also observe limit x tends to a minus f of x is equals to L and limit x tends to a plus f of x is equals to M. In this situation, then we say that limit x tends to a, f of x is equals to does not exist. So this is left hand limit, this is right hand limit. So whenever left hand limit not equals to right hand limit, left hand limit not equals to right hand limit, in that case we say that limit of a function at a particular point does not exist. Okay, see, limit x tends to 2, x square plus 3x plus 5. Limit x tends to 2, x square plus 3x plus 5 can be found by writing in place of x is 2, unless until we get indeterminate form. Let us discuss about indeterminate form. It is 2 square plus 3 into 2 plus 5. 4 plus 6, 10 plus 5 is 15. So limit of this function at 2 is 15. Okay. See, there are 7 indeterminate forms in mathematics. They are infinity by infinity, 0 by 0, infinity minus infinity, 0 into infinity, 1 power infinity, infinity power 0, 0 power 0. Okay, do observe that. These are 7 indeterminate forms. What is the meaning of the word indeterminate forms? In mathematics, there is no question whose solution ending with these forms. They are called indeterminate forms. Infinity minus infinity, don't think it is 0. 0 into infinity, immediately we get an idea 0 into something is 0. 0 into something is 0, but it is 0 into many things. 1 power anything 1, we remember very well. But 1 power infinity, we cannot determine its value. Infinity power 0, you will think about infinity power 0. Anything power 0 is 1, but it is many thing power 0. Don't think it is 1. 0 power 0, we can't say. Infinity by infinity also we can't say. So these are 7 indeterminate forms. Okay. In limits, many questions will give in these forms. Limit x tends to 0, sin x by x, while applying the limit as previous case, sin 0 is 0, x is also 0, we get 0 by 0 form. Sometimes we will have limit x tends to 0, 1 plus x whole power 1 by x. While applying the limit, we get 1 plus 0 is 1 power infinity. So dear students, we are going to discuss about these models now. That is only the limits syllabus. If you learn about these 7 indeterminate forms, limits will be very, very easy. Simply you can get 2 marks. Next, L'Hospital rule. L'Hospital rule. Whenever limit x tends to a, f of x by g of x is equals to 0 by 0 or infinity by infinity forms. Infinity forms. If we get 0 by 0 or infinity by infinity forms, then limit x tends to a, f of x by g of x. Don't apply the limit directly for the given function. Apply the limit for their derivatives. Limit x tends to a, f dash of x by g dash of x. If here also we get 0 by 0 or infinity by infinity form, if limit x tends to a, f dash of x by g dash of x is also 0 by 0 or infinity by infinity forms, these are indeterminate forms, then limit x tends to a, f dash of x by g dash of x, evaluate not by substituting directly, differentiate numerator and denominator separately and then apply the limit, f double dash of x by g double dash of x. Okay. So this is, there is no mandatory to get here a finite value. If we get here also 0 by 0 or infinity by infinity forms, again continue this process, differentiate numerator and denominator separately, then apply the limit. Continue this process till to get a finite limit. Continue this process till to get a finite value. Till to get a finite value. So this is L'Hospital rule. Okay. So we have finished two indeterminate forms, either infinity by infinity or 0 by 0. Okay. Next, suppose limit x tends to a f of x minus g of x is equals to infinity minus infinity form, or limit x tends to a f of x into g of x is equals to 0 into infinity form. So these are also two more indeterminate forms. Then convert them into 0 by 0 or infinity by infinity forms. Then use L'Hospital's rule. Use L'Hospital's rule. We know already what is L'Hospital rule. Okay. So far, how many forms completed? 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity forms finished. Next, another form, see, limit x tends to a f of x whole to the power g of x is equals to 1 power infinity form. Then limit x tends to a f of x whole to the power g of x is equals to e power limit x tends to a g of x into f of x minus 1. G of x into f of x minus 1. Okay. So another L'Hospital rule finished. So far 5 L'Hospital rules completed. Next, if limit x tends to a f of x whole to the power g of x is equals to 0 power 0 or infinity power 0, then limit x tends to a f of x power g of x is equals to e power limit x tends to a g of x into log f of x. Okay. So these are the models in limits. Okay. Do observe that infinity by infinity finished, 0 by 0 finished, infinity minus infinity, 0 into infinity. First 4 models L'Hospital rule based. Next 1 power infinity finished, infinity power 0, 0 power 0 also finished. Okay. One more. We know that limit x tends to 0, 1 by x is equals to infinity. Limit x tends to infinity, 1 by x is equals to 0. Okay. Suppose, for example, limit x tends to infinity, x cube plus 3x square plus 5x plus 7 by x square plus 7x plus 2. Okay. In order to solve such questions, in the numerator, x cube taken out common, 1 plus 3 by x plus 5 by x square plus 7 by x cube. In the denominator, x square taken common, 1 plus 7 by x plus 2 by x square. After the cancellation, in the numerator, infinity times 1 plus 3 by infinity, something by infinity is 0, plus 0 by 1 plus 0 plus 0. So answer is infinity. Whenever the numerator degree is greater than the denominator, answer is 0. See, in the same situation, suppose the question is limit x tends to infinity, x square plus 7x plus 2 by x cube plus 3x square plus 5x plus 7. What will be happening? In the same case, after the cancellation, one more x will be left in the denominator. Whenever something by infinity is left, something by infinity is 0. So, if the denominator degree is more than the numerator, as x tends to infinity, its value is 0. Suppose both numerator and denominator are equal. Denominator degree, numerator degree equal. 2x cube plus 3x square minus 5x plus 7 by 5x cube minus 7x square plus 9x plus 13. Okay. What will be happening this time? X cube taken out common. Whenever x tends to infinity is given, always we need to think about leading x power common. Limit x tends to infinity. 2 plus 3 by x plus 3 by x minus 5 by x square plus 7 by x cube. By denominator, x cube 5 minus 7 by x plus 9 by x square plus 13 by x cube. We know very well that this is 0, 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 gets cancelled. Answer is 2 by 5. Remember that whenever limit x tends to infinity given, numerator denominator degrees are equal, answer will be numerator leading term coefficient by leading term coefficient. 2 by 5 will be the answer. Okay. See, we can write a result here. Limit x tends to infinity, a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on, an minus 1 into x plus an by b0 x power m plus b1 x power m minus 1 plus b2 x power m minus 2 plus and so on, bm minus 1 into x plus bm is equals to, here numerator degree is n, denominator degree is m. Whenever numerator degree greater than the denominator, answer 0. If n greater than m, infinity. Numerator degree is greater than denominator, answer infinity. Next, 0 if denominator degree is greater than numerator, a0 by b0 if n is equals to m. Okay. So this is the situation in case of limit x tends to infinity. Next, so one more concept, that is sandwich theorem. Sandwich theorem says that suppose three functions satisfying this condition, f of x less than or equals to h of x less than or equals to g of x, and limit x tends to a f of x is equals to limit x tends to a g of x is equals to L, then limit x tends to a h of x is equals to L. Limit x tends to a h of x is equals to L. Left side limit, left side function approaches to L. Right side function approaches to L. What it says, middle function is also approaches to L as x tends to a. Okay, so this is the way to find the limit of a function using sandwich theorem. It is called sandwich theorem. Okay. Problem number 1. Limit x tends to 0 plus modulus x by x. See, here there are three problems. To solve these three problems, we are going to use modulus x definition. Modulus x is equals to x if x greater than 0, minus x if x less than 0, is equals to 0 if x is equals to 0. So this is modulus x definition. Modulus x is equals to x when x greater than 0, is equals to minus x when x less than 0, 0 when x is equals to 0. Do observe that x tends to 0 plus stands for x greater than 0. Whenever x greater than 0, mod x will come out as x. That's why limit x tends to 0 plus mod x by x will be limit x tends to 0 plus x by x. After the cancellation, value is 1. Okay, so right hand limit is 1. Next, left hand limit, as we know already, x tends to 0 minus implies x less than 0. When x less than 0, mod x outcome is minus x. That's why limit x tends to 0 minus mod x by x will be limit x tends to 0 minus x by x, which is equals to minus 1. What did you observe here? Right hand limit is 1, left hand limit is minus 1. What about limit of the same function at x tends to 0? Here left hand limit minus 1 as we seen, right hand limit plus 1. Since LHL not equals to RHL, therefore limit x tends to 0 mod x by x does not exist. Okay, limit x tends to 0 mod x by x does not exist because of left hand limit is not equals to right hand limit. Okay, next, problem number 4. Limit x tends to 5 minus step x. Okay, first let us discuss about step x. Step x is equals to x if x belongs to z. Means step of 5 is equals to 5, step of 2 is equals to 2, step of minus 10 is equals to 10 whenever x belongs to z, is equals to immediate left integer on the immediate left integer 2x on the real line whenever x belongs to, if x belongs to r minus z, if x belongs to r minus z. Okay, when x belongs to z will come out as it is. When x belongs to real number other than z, this is the definition. In textbooks, different definitions will give. X minus 1 less than or equals to x less than x plus 1. You will get confusion. Simple. Immediate left integer to x on the real line whenever x is a real number other than integer. For example, you imagine what is a real line. Step of 10 goes to first case because 10 is an integer. Step of 10 will come out as 10. Step of 10.5, see, on the real line 0, 1, 2, 3, so on, 10, 11, these are integers. Minus 1, minus 2, minus 3, minus 4, so on, also integers. But between 9 and 10, we can see some lines. They represents rational and irrational numbers. So 10.5 lies between 10 and 11 integers. So what is the immediate left side integer of 10.5 on the real line? Is 10. So step of 10.5 will be 10. Step of 10.9 also, don't think that it is very closer to 11. Answer is 11. Even for 10.9 also, immediate left side integer is 10 only. Okay. So that's why step of minus 2.3. Coming to left side of 0 on the real line, we can see the numbers minus 1, minus 2, minus 3, minus 4, etc. Minus 2.5 can be seen between minus 2 and minus 3. For minus 2.5, immediate left side integer is minus 3. So that is the meaning of immediate left integer to x on the real line. Yes, coming to this question. Okay. Limit x tends to 5 minus x tends to 5 minus stands for x less than 5. X less than 5 means don't think that x is 2, x is 3, x is 0. Very closer to 5. This implies x value almost 4.9999 something. Now limit x tends to 5 minus step of x will be step of 4.9999 something, which is equals to 4. So step of 4.999 something means its immediate left side integer is 4 only. Coming to next question. Limit x tends to 5 plus. The meaning of the symbol x tends to 5 plus implies x greater than 5. X greater than 5 represents x is equals to 5.0001 something. Now limit x tends to 5 plus, step x will be step of 5.00001 something. Its immediate left side integer is 5. Okay, this is left hand limit, this is right hand limit. As the left hand limit is not equals to right hand limit, limit of a function at 5 does not exist. So limit x tends to 5, step x does not exist. Since LHL equals to 4, RHL equals to 5, LHL not equals to RHL. So this is the clear picture about step function at integer point. Limit of a step function at integer point. Now look at the question number 7. Limit x tends to 7.3. Do observe that in order to decide this also we need to discuss left hand limit as well as right hand limit. 7.3 minus stands for 7.2999 something, which is equals to 7. Coming to right hand limit, while talking about right hand limit, x tends to 7.3 plus step x, which is 7.3000001 something. It is more than 7.3, which is also equals to 7. Since LHL equals to RHL equals to 7, therefore limit x tends to 7.3 step x not only exist, that existing value is a 7. Okay, so this is the way to write limit x tends to 7.3 step x. So what did you observe now? We can write a note point for step function. Limit x tends to a step x is equals to does not exist if a belongs to z. Means just like limit x tends to 2024 step x does not exist, which is equals to step of a if a belongs to r minus z. Means a is other than integer type real number. Okay, for example, limit x tends to 2024 step x does not exist. Limit x tends to 10.5 step x will be step of 10.5, that is equals to 10. Here it is real number other than integer. Here it is real number, integer type real number. So that is the difference. Okay, I think you got clarity on step function limit. Next, limit x tends to 1, 2x minus 3 into root x minus 1 by 2x square plus x minus 3. While applying a limit, let us check what will be happening. While applying the limit means by writing in place of x is 1, if we get other than indeterminate form, that will be the answer. We may get an answer for limit 0. 0 is not an indeterminate form. We can also get answer as infinity. Infinity is not an indeterminate form. Okay, do observe that. While applying the limit, we get 2 into 1 minus 3 minus 1 into root 1 minus 1 0 by 2 plus 1 minus 3. We are getting 0 by 0 form. We have an evidence whenever limit of a function is 0 by 0 form, then how to solve such question? By using L'Hospital rule. So I am calling it as LH rule. Limit x tends to 1. What it says? If you are getting 0 by 0 or infinity by infinity form, then differentiate both numerator and denominator separately and apply the limit. In the numerator, it is UV rule. 2x minus 3 writing as it is, differentiate the second function, plus root x minus 1 as it is, differentiate the first function. In the denominator, 4x plus 1. Okay, now apply the limit. 2 minus 3 minus 1, 1 by 2 into root 1 is 1 plus 0 into 2 by 4 into 1 plus 1. This is minus 1 by 2 by 5, which is equals to minus 1 by 10. Okay, minus 1 by 10. It is defined value. It is a determinate value. It can be our answer. So this is the way to find whenever we get 0 by 0 form. Okay, I think you got clarity. Let's move on to next question. Limit x tends to 0, cos 4x plus a cos 2x plus b by x power 4 is finite. Then the values of a comma b respectively are. Do observe that. Very interesting question and important model also. Limit x tends to 0, cos 4x plus a cos 2x plus b by x power 4. While applying limit we get cos 0 is 1, a plus b by 0. While applying limit cos 0 1, cos 0 1, a into 1 is a plus b. But given that already limit is finite, but we are getting here something by 0 is infinite, which is a contradiction. In order to get finite limit, we need to use L'Hospital rule. We need to proceed further. We should not stop the question at this stage. If we stop here, what will be happening? Answer is infinite, which is contradiction to the hypothesis. That's why, in order to use L'Hospital, when L'Hospital will accept the admission into his hospital whenever it is in the form of 0 by 0 or infinity by infinity only. But it is not in that form. Denominator 0, numerator involving unknown terms. That's why to use L'Hospital rule, numerator should be equals to 0. 1 plus a plus b is equals to 0. That is a plus b is equals to minus 1. Okay. Next, now we have a right to use L'Hospital. That is limit x tends to 0. Derivative of cos 4x minus 4 sin 4x minus 2a sin 2x plus b, this is 0, 4x cube. While applying limit sin 0 0 sin 0 0, we are getting 0 by 0. We got direct permission to use L'Hospital once again. Limit x tends to 0 minus 4 sin 4x. Sin 4x derivative is cos 4x into 4 minus 16 cos 4x. This will be minus 4a cos 2x by denominator 12x square. We are getting this time minus 16 minus 4a in the numerator, 0 in the denominator. Now also, if numerator is non-zero, its value is infinite. So limit of given function is infinite, but which is a contradiction to the hypothesis. We have to proceed L'Hospital till to get a finite value. We have to continue this procedure. In order to get 0 by 0 form, numerator must be equals to 0. Then only it is possible to use L'Hospital. Okay, then only we get finite limit. That's why from this a is equals to minus 4. A is equals to minus 4, substituting here b is equals to minus 4 plus 1, 3. So these are the values of a and b. Very, 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 very important model it is. Okay. Next, let's move on to next question. If f is mapping from R to R is defined by f of x is equals to step of x minus 3 plus modulus x minus 4, where bracket dot is GIF, greatest integer function, means step function, then limit x tends to 3 minus f of x will be limit x tends to 3 minus f of x is nothing but limit x tends to 3 minus step of x minus 3 plus modulus x minus 4. Do observe that x tends to 3 minus stands for x is equals to 2.9 something, which is nothing but 2.9 something minus 3 plus 3 minus 4. This is step of minus 0.1 plus modulus minus 1. This will be step of minus 0.1 value, its immediate left integer is minus 1 plus modulus minus 1 is 1, which is equals to 0. Okay, so this is answer for this question. Very simple. You may get doubt. Here we are substituting 3 minus means 2.9. Here 3. Don't confuse that. While substituting 2.9 it gives different nature. Here if we substitute 2.9 or 3, it is negative nature only. Its nature won't be changed. That's why. Okay. Limit x tends to 1. Limit x tends to 1. 1 minus x into tan pi x by 2. Applying the limit, 1 minus 1 is 0 into tan pi by 2 is infinity. 0 into infinity is indeterminate form. In order to solve such questions, we need to convert the given question into either 0 by 0 or infinity by infinity forms. Now it is converted to 0 by 0 form. Whenever 0 by 0 form, cot pi by 2 is 0. 1 minus 1 is also 0. Whenever 0 by 0 form, we can apply L'Hospital rule. Numerator minus 1, denominator minus cosecant square pi x by 2 into inner derivative is pi by 2. Minus minus cancelled. Okay. 1 by applying the limit cosecant square pi by 2 and it goes to numerator 2 by 5. Cosecant square pi by 2 is 1. So answer is 2 by pi. Okay. So this is answer for this question. 0 into infinity form. We have discussed its working rule. Whenever infinity minus infinity, 0 into infinity, we have to convert them into 0 by 0, infinity by infinity forms. Then after, use L'Hospital rule. Limit x tends to 0. 3 sin x grades minus sin 3x grades by x cube. 3 sin of x grades minus sin 3 theta type it is. 3 sin of x grades minus 4 sin cube of x grades by x cube. X cube, which is equals to limit x tends to 0, 4 sin cube of x grades by x cube. Do observe that 200 grades is equals to pi radians. 1 grade is equals to pi by 200 radians. X grades is equals to pi by 200 x radians. And moreover, limit x tends to 0, sin x by x is equals to 1 is a standard result, or else apply L'Hospital rule. We get same thing. Limit x tends to 0, 4 times sin of pi x by 200 by x whole cube. Okay, we get limit x tends to 0, sin kx by x is equals to k. In the same way, sin kx, here k is pi by 200 times x by x. So answer is pi by 200 whole cube. Pi by 200 whole cube. So important conversion it is. Relation between grades and radians. Next. If 7 minus x square by 2 less than or equals to f of x less than or equals to 7 plus x cube by 5 for all x not equals to 0, then limit extends to 0, f of x is equals to 7 minus x square by 2 less than or equals to f of x less than or equals to 7 plus x cube by 5. Applying a limit for each term with x tends to 0, 7 minus x square by 2 less than or equals to limit extends to 0, f of x less than or equals to limit extends to 0, 7 plus x cube by 5. Okay, here we get 7, however x value is 0, limit extends to 0, f of x less than or equals to, this is also 7. Left side limit is 7, right side limit is 7, therefore limit extends to 0, f of x is equals to 7 by sandwich theorem. By sandwich theorem. Okay. If f of x is equals to x square by 2, 0 less than or equals to x less than 1, 2x square minus 2x plus 3 by 2, 1 less than or equals to x less than or equals to 2. Limit extends to 1, f of x. My dear students, observe this carefully. Limit extends to 1, f of x can be found in two cases. Why? Because x tends to 1 stands for x not equals to 1. X not equals to 1 means x may be greater than 1 or x may be less than 1. Okay. See, x may be greater than 1, less than 1. There are two cases given. X less than 1 case, x greater than 1 case. That's why we need to discuss in two cases, left hand limit, right hand limit. Limit x tends to 1 minus x square by 2, which is equals to 1 by 2. Limit x tends to 1 plus f of x. Limit x tends to 1 plus x value greater than 1 case, 2x square minus 2x plus 3 by 2, which is 2 minus 2 plus 3 by 2 is equals to 3 by 2. So LHL not equals to RHL. That's why, therefore, limit x tends to 1, f of x does not exist. Does not exist. Okay. So this is the way to find limit in such case. Very simple. Limit x tends to infinity, numerator degree greater than denominator, answer infinity. We have discussed already. Very simple. Limit x tends to infinity, denominator degree greater than numerator, answer is 0. Why? Because some more x left in denominator, something by infinity is 0. No need to remember that also. Something by infinity you think. So previous one is infinity, this is 0. Next problem. In case of limit extends to infinity, degrees of numerator and denominator same, directly answer is leading coefficient by leading coefficient. Okay. So this is the way. Next problem. Limit extends to infinity, x square plus 1 by x square minus 1. Do observe that just now we have seen degrees are equal, limit extends to infinity, its value is 1. Power x square is infinity, 1 power infinity form. Whenever given limit is in 1 power infinity form, we can use the formula x square plus 1 by x square minus 1 whole power x square is equals to e power limit x tends to infinity g of x into x square plus 1 by x square minus 1 minus 1. G of x into f of x minus 1. This is g of x, this is f of x. You can check our working rule. E power limit x tends to infinity x square into x square plus 1 minus x square plus 1 by x square minus 1. Now what happens? E power limit x tends to infinity 2x square by x square minus 1. In case of limit x tends to infinity, degrees are same, leading coefficient by leading coefficient. E power 2 by 1, that is e square. E square. Okay? Next. Limit x tends to 0, x square into sine pi by x. Do observe that while applying the limit, x square, 0 square is 0, sine pi by 0, infinity, we don't know what is sine infinity value. That's why minus 1 less than or equals to sine pi by x less than or equals to 1. We know that range of sine function is minus 1 to 1. Multiplying with x square, applying a limit x tends to 0. Limit x tends to 0 minus x square less than or equals to limit x tends to 0 x square into sine pi by x less than or equals to limit x tends to 0 x square. This is 0. This is the limit x tends to 0 x square into sine pi by x. Again we are using sandwich theorem. Left side limit 0, right side limit 0. Definitely middle function limit is also 0. Okay. So this is the way to find. Limit n tends to infinity 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus and so on 1 by 2n minus 1 into 2n plus 1. Do observe that limit n tends to infinity 1 by 2 times 1 by 1 minus 1 by 3. Why? Because 3 minus 1, 2 by 1 into 3 we are going to get, but 2 is not there in the numerator. Divide and multiplied by 2. This will be 1 by 3 minus 1 by 5. 5 minus 3, 2 by 3 into 5 we are going to get. 2 taken out common gets cancelled, will be as it is 1 by 5 minus 1 by 7 plus and so on. Plus and so on. 1 by 2n minus 1 minus 1 by 2n plus 1. Cancelled, 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 cancelled. So what are the terms left with us? Limit n tends to infinity 1 by 2 times 1 minus 1 by 2n plus 1, which is nothing but limit n tends to infinity 1 by 2 into 2n plus 1 minus 1 by 2n plus 1. Degrees are equal. N tends to infinity is there. Degrees are equal. 4n plus 2, which is equals to 2 by 4, 1 by 2. In case of degrees are equal, coefficient by coefficient, 1 by 2 answer. Okay, very simple to find when continued series also given. Limit x tends to 0, tan 3x by x, we are getting 0 by 0 form. 0 by 0 form. Use L'Hospital. 3 times secant square 3x, tan derivative secant square 3x, inner derivative 3 by 1, applying limit secant square 0, which is 3 into 1 is equals to 3. Very simple question, 0 by 0 form. Limit x tends to 0, 1 minus cos 3x by x square, applying limit 1 minus 1 by 0, 0 by 0 form. Use L'Hospital rule. While using L'Hospital rule, numerator 3 sin 3x by denominator 2x. If you get still 0 by 0 form, if you remember the result, it is okay. Otherwise, actually its value is 3. Otherwise, use L'Hospital again. If you don't remember that, 9 into cos 3x by 2. This is 9 into 1 by 2. 9 by 2 answer. Okay. Next problem. Limit extends to 2. 1 by x minus 2 minus 1 by x square minus 4. While applying the limit, we are getting 1 by 0 minus 1 by 0, infinity minus infinity forms. Whenever infinity minus infinity form is there, we have to convert it into 0 by 0 or infinity by infinity. Then use L'Hospital. Do observe that LCM is x square minus 4. Already x minus 2 is there. This is nothing but x minus 2 into x plus 2. X minus 2 gone. More x plus 2 will come in the numerator, minus 1. So limit x tends to 2. In the numerator, x minus 1 by denominator x square minus 4. Now 2 minus 1 by 0, 1 by 0, infinity. What we have discussed, answer can be infinity. Okay, answer can be 0, but should not be 0 by 0, infinity by infinity, infinity minus infinity forms. Next, limit extends to 0, x cot x. X is 0, cot 0 is infinity. 0 into infinity form. That's why limit extends to 0, x by tan x. Now converted to 0 by 0 form. In case of 0 by 0, limit extends to 0, 1 by secant square x, 1 by secant square 0, 1 by 1 is 1. Simple question. 0 into infinity form can be converted to either 0 by 0 or infinity by infinity form. Next, limit extends to 0, cos ax minus cos bx by x square. While applying a limit, what we are going to get? Cos 0 1, cos 0 1, 0 by 0 form. Then we have to use L'Hospital. Minus a sin ax plus b sin bx by 2x. Applying limit again, 0 by 0 form we are getting. That's why limit extends to 0, minus a square cos ax plus b square cos bx by 2. Applying limit, minus a square into 1 plus b square into 1 by 2, which is b square minus a square by 2. So my dear friends, these are sure short questions. Definitely you will get 1 mark from this. Please like, share and subscribe my YouTube channel Srinivasa Academy and encourage me to do more and more videos for you. Thank you one and all.